Alright, we have still saved the data frame df, and in the last lecture we have found out that the income should be the most important feature to forecast house prices. And let's again have a look at the median income, and let's create a histogram with 50 bins. And again we can see that the median income is already scaled to values between 1 and 15, and it's also capped at a value of 15. Now, sometimes it can be beneficial to transform a numerical feature into a categorical feature with, for example, 5 categories. And in our example, there could be the low income bin, the below average income bin, the above average, the high, and the very high income bin. So these are 5 income bins. And this is called discretization or binning, and there are several ways how to do it. And either we could define intervals, for instance, all median incomes from 0 to 2 are organized in the low income bin and so on. So that's the first way, or the second alternative is that we could define quantiles or percentiles, and we could say that the lowest 25% in terms of income belong to the low income bin and so on. And that's exactly what we will do in the next few lines. So we discretize or bin the numerical feature median income into 5 bins with pd.qcut, and actually Q stands for quantile. And first of all, we pass the column median income, and then we define the quantiles, or more correct, the percentiles. And we could say that the 25% lowest income districts are organized in the first bin, so from 0 till the 25th percentile. Then we have the next bin from the 25th percentile to the 50th percentile. Then we have the third bin from the 50th to the 75th percentile. Next, we have the fourth bin from the 75th percentile to the 95th percentile. And finally, we have the 5% of all districts with the highest income. So let's have a look here. And first of all, let's have a look below. So we have 5 income categories. The first one from 0.5 to 2.5, then the second from 2.5 till 3.5, and so on. And the highest 5% are between 7.3 and 15. And actually now we can see for each and every district the interval that the district belongs to. For instance, the first district's income is between 7.3 and 15, so that's the highest income category. And actually, instead of having the intervals here, we could also assign a label, and there's the additional parameter label. And here we can say that for the lowest bin we want to have low, then for the next below average, then above average, high, and very high. And with this we can create and save a new column, income categories. And let's have a look here. So here we have for the first district very high, also for the second, and so on. And we can actually see that here we have so-called ordered categories. So we are starting with low, and low is lower than below average, and this is lower than above average, and so on. And now we can also call the value counts method, but instead of getting the absolute counts, we can also get the relative counts by passing true to normalize. And actually now we should get 25% for the low category, then also 25% for below average, and 25% for above average, and 20% for high, and finally 5% for very high. So let's have a look here. And indeed we have 25%, 25%, and again 25, 20, and 5%. So due to rounding issues, we do not have exactly 25%, but these are actually minor differences here. And now we can create a Seaborn count plot, and we pass df to the data parameter. And on the x-axis, we want to have the income categories. And let's have a look first of all. So here we have on the x-axis the income categories and actually the count. And actually within the income categories, we make another split. So we split up into the ocean proximity, nearby, less than 1 hour to the ocean, inland, near ocean, and island. And let's have a look here at the low income category. And here we can see that districts with a low median income are mainly located in the inland. And once we increase the income category, the count of inland decreases and the count of nearby or less than 1 hour to the ocean increases. So let's have a look at the very high income category. And districts with a very high median income are mainly located near the ocean, so less than 1 hour. Now let's go on. And we can also create a Seaborn bar plot with the income category on the x-axis and the median house values on the y-axis. So let's have a look here. And this graph simply says that the higher the median income in a district, the higher the median house values. So if we have a district with a low median income, then the average house value is around about 120,000. And for the very high income category, we have an average median house value of around about 450,000. Next, we can also create a Seaborn bar plot where we have on the x-axis ocean proximity and on the y-axis the median house value. And actually here we can see that nearby, less than 1 hour to the ocean, and near the ocean are very close together in terms of median house value. So they are between 230 and maybe 280,000. And actually we could ignore island because here we have only 5 districts. And finally we have inland, and the median house value of districts that are located in the inland are clearly lower than districts near the ocean. And as a side note, the height of the bars are point estimates for the average median house value, and the small black lines show the 95% confidence intervals. And to simplify things, we could also merge the categories nearby, 1 hour to the ocean, and near the ocean into one category. But let's leave it as it is here, and let's go on. And finally, we could group DF by the income category and by the ocean proximity. So these are the 2 categorical features. And then we calculate the average value in the median house value. And then we unstack and we drop the island because this is not really meaningful. Here we have only 5 observations. And we save the resulting matrix in the variable matrix. And we transform the floats into integers, so this makes it easier to display the median income in our following heat map. So we create a Seaborn heat map. And first of all, let's simply have a look here. So we have on the x-axis the ocean proximity, and on the y-axis the income categories. And we have actually here a color bar or a color map with reds. And light red means that the income, the median income, is around about 100,000. And dark red stands for a median income of 450,000 or more. So we used here the color map reds, and we actually also annotated the values here by passing true to the anode parameter. And we actually scaled the color map in a way that we have the minimum values, so very light red at 90,000 and the maximum value at 470,000. And actually it's no surprise that we can find the highest house values in districts where we have a combination of very high income and the location near the ocean. And we have the lowest income in the combination inland and the low income. And also we can see that there's no big difference between the categories minus 1 hour to the ocean, nearby, and near ocean. However, we can clearly see the difference of those 3 categories to the category inland. Alright, this was the explanatory data analysis, and now we know a lot about our data and the relationships between features and label. And now we are best prepared to create our machine learning model. Thanks for watching, and see you in the next lectures. Bye.